In chapter 3, we're going to take what we learned in last chapter with linear equations. We're going to now look at system of linear equations and then also other system as well. So the question first is, what does system mean? System of equation means a set of equations. So there's going to be more than one now. And then the linear system, remember the word linear comes from the word line. And line means a straight line. So this is like a diagonal line, something like that. That's called a linear line. So then linear system means a system with linear equations. Linear equation, again, comes from the word line. So linear equation is just where the equation has a variable with the highest degree of 1. All right. Now another word here, degree. What does degree mean? So for example, if we have a linear equation of 2x. So the question you ask yourself is, what is the degree? Degree means what is the highest exponent in that equation. So when x has nothing next to it, we know that it has a actually invisible exponent of 1. So then the highest degree in this equation is 1, which means this is a degree of 1. So all linear equations have a highest degree of 1. All right, so another word, solution. So what does solution mean? When they say solve this problem or find a solution, it means a set of solutions that will make all the equations in the system true. So basically, all of these numbers will work in this system. So for example, we're going to look at 3 ways to find the solution to a system. The first method is called graphing. The second method is called substitution. And then the third method is called elimination. So this is a set or a system of linear equations. So in this one, what we want to do is solve by graphing. So pretty easy. The first one, 2x plus 3, we start at 3 and it has a slope of 2, up 2 over 1, up 2 over 1, or down 2 to the left 1. So the trick is draw a very straight line. All right, the second equation is negative 2x minus 1, start at negative 1, go down 2 over 1, down 2 over 1. All right, so the question is, where do they intersect? That is the solution, and it is at negative 1, negative 1. Negative 1, positive 1. All right, let's have you pause the video and try this one. Find the solution by graphing. So you got to get everything into y equals mx plus b first. Okay, go ahead and check your answer. The 2 lines intersect at negative 4, 2. Now let's try this one. So y equals 2x minus 3, negative 3, and it has a positive slope of 2. And then the second one, we're going to change it. So y equals 2x plus 1. Oops, sorry. All right, so then the question is, what is the solution? Well, these 2 lines are parallel, so there's no solution. And then, so the other question you can ask yourself is, what's going to cause a no solution to happen? What's going to cause a no solution to happen? When 2 lines are parallel, right? When 2 lines are parallel, they can never intersect. But what's going to cause something to have a parallel, to cause 2 lines to have to be parallel? Well, we would say the slopes are equal. So does it mean that every time 2 lines have the same slope, they will have no solution? No. If 2 lines are parallel, but their y-intercepts are the same, then they are essentially, so 2 lines that are parallel, but then their y-intercept is the same, then they are basically the same line. They are on top of each other. So that is not a no solution. That is an infinitely many solution. So let's look at these 3 possible outcomes. So the first one you have a 2x plus 1. So start at 1, goes slope of 2. And then the second one, start at -1 with a slope of -2. The question is, do they intersect somewhere? Yes, they do intersect somewhere. And why is that? Because the slopes are different. If the slopes are different, that means they're slanting differently, then they eventually will intersect. So this is one solution, and then how can you tell it's one solution from just looking at the equation? The slope. The slopes have to be different. The next one. If I divide by 2 on the second one, I get y equals 2x plus 1. And you can see that it's actually exactly the same as the first equation. So it's a y-intercept of 2 with slope, y-intercept of 1 with a slope of 2. And then the second line is exactly the same, so they're right on top. So then the question you ask yourself is, what is the solution to this system of linear equation? Well, the question is, where do they intersect? Well, they intersect everywhere. So then this is called infinitely many solutions. And then what makes it infinitely many solutions? When they're exactly the same line, that means the slopes are the same, and then the intercepts are the same. The y-intercepts are the same. The third kind, so one starts at 1 and a slope of 2 again. The second one starts at 3 with a slope of 2. So how many solutions does this have? This one has no solution because they are parallel. But not only are they parallel, they have different y-intercept. Okay, so let's go ahead and have you pause the video and then try these 3. What you're going to do is you're going to figure out if it has one solution, infinitely many solution, or no solution, just based on slope and y-intercept. All right, go ahead and check your answer. What you're doing is just checking for the slope and y-intercept. All right, now let's look at a word problem. So let's look at the first one. You bought a total of 6 pens and pencils for $4. If each pen costs $1 each and each pencil costs 50 cents each, how many pens and pencils did you buy? Okay, when you look at word problems, the first thing you should always do is look at the question. How many pens and pencils did you buy is ultimately what we want to solve. So that means so then you ask yourself, what are the variables? Well, I'm trying to find pens and pencils, so those are my variables. So I'm going to call one of them x, the other one y. Okay, now go back to the actual question, and then you ask yourself, what kind of information are they giving me? Well, there are 2 things. One, the quantity. So there's a total of 6. So that's the quantity. The second is the cost. So there's, the cost for each one and then how much money you actually have. All right, so when we write a system of equation for this, we need 2 equations, one for cost, one for quantity. The first thing says total of 6 pens and pencils, so that means x plus y is 6. The second thing says this person or you did spend $4, and then the pens cost $1. $1 each, pencil costs 50 cents each. So that's $1 for the pen and then 50 cents for the pencil. And then that's a total of $4. So then if we were to solve this using graphing, we would say y is equal to negative x plus 6. And then this one is 0.5y equals minus x plus 4 divided by 0.5. Oops. Not the negative. Y is equal to, all right, -1 divided by 0.5 is not -1/2. It is actually -2. So if you're not sure, you can use the calculator, but really it's just saying -1 divided by 1/2. So number divided by a fraction is the same as number multiplied by the reciprocal of the fraction. So that's -2. All right, so same idea here. 4 divided by half is 8. Okay, so graphing it, so we start with the first line, start at 6, down 1 over 1. And then the second one, start at 8, and then this is down 2 over 1. Sometimes it helps just to draw more points. So then the question is, where do they intersect? They intersect at 2, 4. So what does 2, 4 mean? Remember, we can't just say 2, 4 is the answer. We're being asked how many pens, how many pencils. So 2 pens, 4 pencils. So make sure you answer the question. All right, next one. So let's go ahead and have you try number 1 on your own. All right, for this question, one of the number is 8, one of the number is 4. In the second section, we're going to solve by algebraic methods, which are substitution and elimination. So how do you know when to use substitution, when to use elimination? Well, very easy. The first thing, let's look at substitution. Why do we want to use substitution on this problem instead of elimination? Of course, you can use both methods, but the variable that is by itself is an indication that substitution is easier. So the variable by itself, you want to first identify that. And then what you're going to do is change the equation so that the variable is by itself. And then you're going to take this information and then put it into the other equation that has that variable by itself. So 3x plus 4 times negative 2x plus 10 equals 12. So 3x plus, minus 8x plus 40 equals 12. Minus 5x plus 40 equals 12, minus 40 on both sides. So minus 5x is equal to negative, 28. So x is equal to 28 over 5. When you solve system of equation, remember we're trying to find the same kind of solution as in graphing. That means we're actually looking for a point, not just an x or not just an y. We need to find x and y. So then the next thing is we got to find y. Well, the fastest way to find y is we know that y is equal to something because we wrote it out. We're just going to substitute it back. Y is equal to negative 2 times 28 over 5 plus 10. So let's go ahead and solve this. So negative 2 times 28 is negative 56 over 5 plus 10. We need common denominator, so multiply by 5 over 5. Negative 56 over 5 plus 50 over 5. So this is negative 6 over 5. So that means it's intersecting at this point 28 over 5, comma, negative 6 over 5. All right, let's have you practice this one. So again, find the variable that's by itself and use substitution. Okay, the answer to this one is negative 5 over 2, 5 over 2. All right, so next one, let's review elimination. Elimination is pretty easy to kind of follow. They're usually just kind of one case. What you want to do is you want to get rid of a variable. So you want to somehow look for the variable that you want to get rid of. So if you look at the system of equation here, it's very clear. If you added the two equations together, 4x will cancel out. And that's because they have the same coefficient but opposite signs. So then what we do is we add it together. This cancels out. We have a 5y equals 25. So y is equal to 5. And then what we want to do is find x, and you can plug it back into any one of those. I usually plug into the one that has less negative numbers. So 4x plus 2 times 5 equals 9. 4x plus 10 equals 9. 4x equals negative 1. X is negative 1/4. So then the point is negative 1/4, 5. All right, really quickly, let's have you practice number 1. Okay, the answer is 40. Now let's skip number 2 because I think you know how to do this. Let's do number 3 because we don't like fractions as much. All right, so let's look at this one. There are 2 ways to do this. One is you just kind of bear through it with all the fractions, which is totally fine. The other way is that you don't mess with any of the fractions. Then you have to try to get rid of all the fractions at once. So it's really up to you. Do you like fractions or do you not like fractions? So for me, what I'm going to do is get rid of all the fractions at once. So what you want to do is look at the denominator. So to get rid of all the denominators at once, you have to multiply by the least common denominator. So between 2 and 3, what is the least common denominator? And that would be 6. So if I multiply by 6, I distribute it over. So 6 times, the first one is 1/2 x. 6 times 1/2 x, or really 6 times 1/2 is 3. So 3x plus 6 times 2/3. The 6 and the 3 in the denominator cancels out to get 2. So 2 times 2 is 4. So 4y equals 6. All right, same thing in the second equation. The least common denominator between 4 and 3. 4 and 3. That would be 12. So then multiply by 12. Distribute to every term. 12 times 3/4. The 12 and the 4 cancels out to get 3. 3 times the numerator 3 gets you 9. 9x. Minus 12 times 1/3, that is 4. Well, it looks very nice right now. We have a 4y and a minus 4y. We can just add straight down. So 12x equals 30. Yes. And then divide by 12. We get x equals 30 over 12. And we got to simplify that. So the 6 goes into both. So 5 over 2. Remember, this is not it. We need to find y as well. What you can do is, instead of going back to the original equation that has a lot of fractions, you could just choose any one of these that you change because it's essentially the same equation. All right, so 3 times 5 over 2 plus 4y equals 6. So this is 15 over 2 plus 4y equals 6. I guess we still have to do some fraction unless you really want to multiply by least common denominator again, but this is, not too bad compared to what we had before, so let's just bear with it. Okay, 6 minus 15 over 2, so multiply by 2 over 2. 4y equals 12 over 2 minus 15 over 2, which is minus 3 over 2. And the last thing we're going to do is divide by 4. So y is equal to -3/2 divided by 4. Divided by 4 is the same thing as multiplied by reciprocal of 4. That is 1/4. So -3/8. So then that means the point at which they're intersecting is at 5/2, -3/8. All right, let's really quickly and have you practice with these 3 questions down here. So these 3 questions, go ahead and solve them. Hopefully you realize that only one of them is solvable. So when you get this one, obviously the answer is what it is. But the other 2 is a often confusing point. Which one means what? Well, 0 equals 0 is basically a true statement. So then we would say this is infinitely many solutions. Because you could put any number in for x and then you would still be able to solve it. The second one is 0 equals 16, or really just the 2 sides are not equal to each other, or it's a false statement. So that means no matter what x you put in, it won't work. And then the third one is just one solution because you've just found the solution. Okay, let's have you try this one. Find the value of A that makes each system a dependent system. Well, we don't have to call it dependent. It's basically infinitely many system. Infinitely many solution. So on your homework, you can use dependent, independent, inconsistent, or something like that, or you can just use what we did in class, infinitely many, no solution, or one solution. Okay, so find a number A that makes this infinitely many solutions. So go ahead and give it a try. Well, changing most of them to y equals mx plus b, we realize that in order for it to be infinitely many solutions, it has to be parallel lines, but basically the same line. So that makes it very easy. A must be -2. All right, let's go ahead and practice word problem again. Go ahead and give this one a try. I think it's not a hard one, but this time you're going to solve it using elimination or substitution. All right, let's look at this question. So first thing is, again, you want to look at the question. So write a system of equation, which we did, to find the number of large coffees, large cup of coffee. Only large, not the regular one. So the first thing I did was I gave it a variable. I gave each one a variable. So make sure you label on your work. So then x plus y is 5 because they bought 5 coffee, and then the amount, the cost. So $1 for regular and then 1.5 for large, and then the total they spent was 6. And then so you try to solve it. So since the two x's are the same coefficient, but they're not the opposite signs, so we multiply by -1 to make sure they're opposite signs. And then you solve, you get y equals 2, which is exactly what we want, so we're done. You don't have to put 2 large cups if you have already labeled it somewhere on your homework or on the problem. All right, give this last one a try. All right, go ahead and check your answer. There are 7 $1 bills and 8 $5 bills.